In this video, we're going to take a look at a differentiation rule called the product rule. And how the product rule works is when given any function in the form f of x times g of x, so two functions of x multiplied together, the derivative of this function f of x times g of x will be given by f prime of x times g of x, so the derivative of the first function times the second left alone, plus f of x times g of x, the first function times the derivative of the second. And so this formula is a bit longer than some of the basic rules you may have already seen up to this point. And what's important is that we remember that the derivative of f of x times g of x will not and cannot equal f prime of x times g prime of x. To better see why that must happen, I would suggest looking at a video showing a proof of this rule. But if that's not something that interests you right now, maybe something you want to look at later, we're going to go straight into an example where we must apply this product rule. And so our example, let's set up the function h of x equals x squared times e to the x. Two functions of x being multiplied. And I'll give a small organization tip that you may use. If you choose not to, that's okay. But what I'm going to do to organize this is set up my two functions. I'll call the first one f of x, that'll be x squared, and my second function is e to the x. And then off to the side, I'll differentiate both these functions. The derivative of x squared is 2x, and the derivative of e to the x is e to the x. And having that organization now allows me to just drop these functions into the formula. So h prime of x will equal 2x times e to the x, derivative of the first times the second left alone, plus x squared times e to the x, the first function times the derivative of the second. And that's it. You could do some stuff with factoring here. In certain cases, you might be able to simplify further. I'm not too worried on it for that initial example, but we're going to jump into two more examples right away to highlight when this rule is necessary versus when it's not really necessary. Because it's a more complicated rule, so if you could avoid it, that wouldn't be a bad thing. And so let's take a look at one more example like the starting example where the product rule is going to be necessary. Now let's set up the function k of x equals, and for this one let's go with e to the x again, but this time we'll multiply it by sine of x. So how we're going to know it's necessary? Well, what we do have two functions that are both functions of x, and neither one's a constant. The two functions are being multiplied, so we have a product here. And the biggest thing is we can't combine these. We can't actually carry out this multiplication. This is always going to be e to the x times sine of x. There's no identity or anything like that that can get us out of this function. And so we'll set up our two functions, call the first function e to the x, our second function is sine of x. The derivative of the first function will be e to the x again, and the derivative of our second function would be cosine of x. And now all we need to do is drop this into the formula. K prime of x will be the derivative of the first times the second left alone, or e to the x times sine of x, plus the first function left alone times the derivative of the second, which is cosine of x. And so for this form is fine to leave it this way. You could also, if you choose, factor out an e to the x just to make it maybe a little easier to read, and write this as e to the x times the quantity sine of x plus cosine of x. And that sort of process, that sort of end result, will be useful later on. So keep in mind things like simplifying and factoring for future problems. And now we'll contrast that with an example where it's not really necessary to use the product rule. Let's set up m of x equals x squared times square root of x. So it's definitely a product of two functions of x, so you could use product rule. It would work, it's going to give something equivalent, but it's more steps. If I instead read this as x squared times x to the 1/2 power, I could use exponent laws and say that this is really overall equivalent to x to the 5 halves, which means I can just use power rule to differentiate this, and m prime of x would equal 5 halves x to the 3 halves. If you did product rule and simplified everything down, you could get this same exact expression. It would just take more steps and leave you with more room for errors. So that's it on product rule. Biggest thing is just learning how to recognize when this must be used and when you might be able to get around using it. Thank you for watching.